So one of the homework problems for tonight's homework is asking to verify a given linear approximation about the reference point a equals 0, right? And then determine the values of x for which the linear approximation is accurate to within 0.1. So on the homework, the problem was actually this one right here. So to kind of illustrate the procedures, we're going to do this one and then ask you to transfer that knowledge to the other situation. Let's start with the verifying the given linear approximation. What do they mean by this? Well, we discussed the fact that in class, when you have some function, in this case, the function being f of x is 1 plus x to the negative 3, there are situations where instead of using the actual values of this function, we'd like to approximate it with a line, the tangent line to the graph of this, near some reference point. In this case, the reference point is a equals 0. Okay. So in class, we derived a formula for doing that, which said that as long as I take a point which is close to the reference point, the value of the function will be approximately the value at a plus the slope times the change in x, right? And in fact, we derived this formula by looking at the equation of the tangent line at a f of a. So in our problem here, our function f of x is 1 plus x to the negative 3. So its derivative is just negative 3, 1 plus x to the negative 4. So since we want a equals 0, plugging in a equals 0 into f, we get 1. Plugging in a equals 0 right here into f primed, right, we get negative 3. And since a is 0, this just becomes x. And that indeed leads us to the approximation 1 minus 3x, which is sort of what they're asking us to verify. So the first part is just to check that you get the right thing here. Okay. Now the second part about the accuracy to within 0.1, what that means is that if I look at the value of the function f, okay, right, and I look at the difference between that and the approximating function, in this case 1 minus 3x, then that difference should be bounded between 0.1 and negative 0.1, meaning that the difference between these two functions, so the error made should not be greater than 0.1, right? So to investigate problems like these, I'm going to introduce you to an online tool called Wolfram Alpha, which can be useful in kind of quickly plotting functions and getting an idea of what they look at. So this is, if you just Google Wolfram Alpha, you'll get a link which will take you to this page, and it says, enter what you want to calculate or know about, a very broad sweeping statement. And actually, Wolfram Alpha is fairly powerful in terms of what you can do quickly and relatively easily. So to start off, recall that what we wanted to do was we wanted to take the function 1 plus x, right, plus x to the negative 3, right? And we wanted to see how far away it was from this function 1 minus 3x we were trying to approximate. And we only want to do this near 0. So I'm going to choose an interval of for x equal negative 0.5 to x equal 0.5. So we're going to try and plot this function during this range and then see if we can get an idea of what's going on here. Okay. So relatively quickly, it does produce the following plot. Okay. And you can see that, for example, here, once we get outside the range, so here on the y-axis, this is 0.5, right? So 0.1 would be down here. So looking at this plot, it looks like the difference between these two, first of all, the difference is always positive, and it looks like it's less than 0.1, somewhere around here, right? Which would be, 1 point something on the x-axis and negative 1 point something on the x-axis. It looks like we're kind of like bounded within those regions here. Okay. To figure out the exact values, what we can do is we can just solve for when this difference is actually equal to 0.1 for the variable x. And in this case, we get some solutions which are imaginary that don't make sense. But 2 here, which sort of corresponded well to the graph we had in the previous one, right? So x is negative 0.116 to x is 0.144. So we could say that within this interval of values, the difference between these functions is the error made, or in other words, the error made by this and approximating this is at most 0.1.